Hello, Professor. So here's the working computer. Um, so first things first, we'll start with the more simpler programs. So to start off, let's start off with a simple Hello World program. So the main way that we program this computer is through the EEPROM that is on the computer using this EEPROM programmer. So let me take it out for you and program it with the Hello World program and see this simple program on how it works. Let's try it out. Now you plug in the computer. We reset it a couple times. And as we can see, we have a clear Hello World signal. Hello World message, I should say. How about something a lot more interesting? Well, let's visit the very first UART program that we wrote. This program allows us to communicate using the RS-232 interface with a modern computer. So we can play with it in the terminal. Let's put it on the computer. Let's plug it in. Reset the display. Let's see. I have the program running right here. And as we can see, let me clear this. Now it's cleared. Anytime I press the button, there's a little message that shows up. A little hello world. And as we type on the keyboard in this terminal, that little hello, it shows up also on our LCD display. So let's try and visit something a lot more interesting now. Steve Wozniak's code for the Apple One. So let's program this. Let's reset our computer. And now, if we go into our terminal, oh, we might have to reset this. Now, if we go into our terminal and we reset the computer, we can see the beginning of the Apple One program. So let's get into the screen recording to see it in action. We have Apple One running on our breadboard computer and connected to our terminal right here through our RS-232 connection. So what can we do with this? At first, let's check out the program itself. So let's maybe try and read from memory location 8000, which is where ROM starts, to maybe 8000 FF. And let's compare it to the hex dump of our program. So right here. So as we can see, A9, 1F, 8D, 03, well, it's the program right here. Let's maybe look at the reset vectors. So FFFC, whoops, screwed that up. So as we can see, it's little endian. So it starts at 8000, which is where we saw the program started. And now finally, the long awaited, let's visit MS Basic. Let's try it out. As we can see, we have the start of the Wasmore program. But let's jump into the screen recording and see how to launch MS Basic from it. To run MS Basic, this program that we have right now on the EEPROM has both Apple One and MS Basic. So to find where MS Basic is, we can go to the label file, and we can see the cold start address for MS Basic is at 9F12. So if we come back here and we write 9F12 and then we run the program, we can see that we are running MS Basic. So at first it asks us for the memory size. So if we just press enter, we can it'll automatically detect memory, terminal width. Just skip this, and here we are in MS Basic. And actually, let me go back here, and I forgot to show you a little Easter egg that I learned about also. So if we go back to 9F12 and then we run, here if we type A, we can see the authors, the original authors, including Bill Gates and the first employee, I believe, from Microsoft. So if we just skip this again, here we are in MS Basic. Now, let's try and write a little counting loop to start with. So let's try with new. So here's our program, and here it is. Let's try a simple Fibonacci sequence now. We can maybe showcase this underscore to show a backspace, because I made a little mistake. So let's run this, and here we go. We have the first 10 numbers of the Fibonacci sequence. So well, I'm not sure if these are quite correct, but I'm pretty sure yeah, these make sense. There it is.